My name is Roch. I work as a Scala developer at Misterbell in Paris. For those who don't know our company yet, Misterbell is a French mobile advertising company. We have offices in Paris, London, Rio, and recently we opened one in Berlin. When I joined the company, we decided to move the entire platform from PHP to Scala. We needed something that could sustain our fast growth. As part of our stack, we use Play Framework along with graph databases such as Titan. Scala was de facto our CTO's first choice for the backend APIs, not only because it would help us solve real-time challenges, but also because a statically typed language would help us deliver the best quality we could. In advertising, when you lose a customer, he is not coming back later. This is why every minute of downtime in production is really bad, and we really wanted to stress on quality. That leads me to today's topic, quality assurance with Scala, with the following basic question: what are the tools available and how can it help you with your current projects? In this presentation, I will detail how you can set up a quality assurance process with open source tools. You will see that QA is not only for big companies. Be aware, this talk is actually not very technical. The idea is to give you some tips and feedbacks with my experience with QA at Misterbell, and I will try to keep it as precise and concise as possible. Okay, let's start by defining what this is all about. A quality assurance process is here to help you with the automation of your quality check task. And this is why it's worth it. Because if you don't test, your production is going to look bad. So yeah, why is it worth it? Of course, you can run tests on your local machine while you're working on it. But when you work in teams on the same project, some people might forget to do that. The integration and merging of each developer's changes can be painful. And yeah, that also applies to open source development. I mean, who never forgets to push code before, who never forgets to test code before pushing it? Quality assurance is here to protect you when it happens. You make the rules and it protects your workflow. As we will see later, there are plenty of other things you can do with quality assurance and by automating your development process. So, a first important term to keep in mind is continuous integration. Continuous integration will help you automate everything. The most common way to integrate CI in your development process is to trigger it each time someone pushes code on the project's repository. There are a few available on the market. I've actually tried 3 of them. They are all compatible with Scala. Jenkins is great, but it's a bit heavy. It does pretty much everything. There are many plugins available. You might want to keep CI to what it's really all about, building your project and running your test. On the other hand, Travis is lightweight. It only does what you expect it to do. You add a small YML configuration file at the root of the project, and it runs it. And finally, GitLab CI is a new tool, open source and self-hosted. It was kind of a fight to get it running, but it's a nice alternative as well. So now that we've defined what is a quality assurance process and CI, let's talk about code coverage. First, to define code coverage, it is a measure of how much of your code is actually tested. So yeah, that's a pretty useful metrics you might want to keep in sight. Before we go a bit deeper into code coverage analysis, let's focus for a few minutes on the different kind of code coverage techniques. There are mainly 3 of them: line level coverage, statement level coverage, and branch level coverage. Many code coverage libraries were line-based, and that's usually fine for verbose languages like Java. When you want to instrument a language like Scala, it's a bit more complex. As you can see on this example, you can have more than one statement in one line. If you test for age equal 18, you would get 100% line level coverage. But with the same test, you only get 50% statement covered. If you want to get to 100% statement covered, you will need to add a new test, which tests age is bigger than 18. So yeah, in this test, beer for you was reached, but no beer hasn't been tested. We would need to do the other test to reach full coverage. So now let's face line level coverage with branch level coverage. Looking at the example we have here, we can see that the result obtained with linear coverage will have tested 4 lines over 5, which is 80%. With branch coverage, you would only get 50%. So yeah, if the true condition, I mean, in the first branch you have 4 lines of code. So if you do branch level coverage, you would only get like 50% because it doesn't take into account how many statements you have. So yeah, what is the big difference between statement level coverage and branch level coverage then? With branch level coverage, it doesn't really matter if all your statements are tested. It also expects you to test more than that. It will make sure you have tested each possible condition. So in this case, we haven't tested our if condition against a false value, the 2 if conditions you have. So with Scala, if branch level coverage is properly implemented, it will need to support the following symbols: if, else statements, match statements, partial function cases, and try-catch finally clauses. Okay, so these are the code coverage available you can use. Once again, there are a few options available, and SCCT, SCOVERAGE, and Jacoco for SBT are the 3 most popular ones. SCCT was essentially line-based, and the project was no longer active. It had actually been given up upon about 2 years ago. And there was still a lot of pull requests waiting around, showing great interest into the project. So as I just started working on Scala, I decided to initiate a few releases. They underlined the fact that SCCT was facing one main issue of being a line-level coverage project only. And most people were asking for statement-level coverage, which is normal with Scala. It makes more sense. So yeah, I made a few releases of SCCT, which included some pull requests and this extra feature of statement-level coverage. But the project really needed a deep cleanup. So that's when Samuel started working on it as well. And he recentered the project on statement-level coverage. So yeah, SCOVERAGE is based on SCCT, but its entire code base has been cleaned up, and it allows you to do statement level coverage along with branch level coverage. Jacoco for SBT is a SBT plugin, obviously. It allows you to use Jacoco. Jacoco is the Java code coverage library. It uses a different approach on instrumentation. We will see a bit later what are the differences between bytecode instrumentation and AST instrumentation. With bytecode instrumentation, code coverage has to be collected at runtime. For this purpose, Jacoco creates instrumented version of your class definition, and the instrumentation process happens on the fly during the class loading using Java agent. This method is pretty fast, and it works well when you want to instrument Java code. But we are interested about Scala. So, unfortunately, Scala creates a way more complicated bytecode output. One Scala statement doesn't always generate one bytecode OP. So sometimes it does more. For instance, in the case of a match symbol. Okay, so let me give you a quick example of what you would get if you try to instrument Scala using bytecode. Let's say you're going to use line level coverage, and you have two statements to test, two lines of Scala to test. So the first line compiles to 100 bytecode, and the second line compiles to 10 bytecodes. So if you only execute the second line, you would get 10 over 110 lines covered. So that gives you around 9% of coverage, when really it should be about 50%. This is why SCOVERAGE decided to use a different approach, which is the AST. AST stands for Abstract Syntax Tree. It goes through a tree representation of your source code and of the project, and it checks for which statements are tested. The Scala compiler offers a nice hook into AST, so it's very convenient to use it. But with Java, you don't have this kind of facility. One of the great advantages of SCOVERAGE is its modularity. It includes different kinds of plugins. For code instrumentation, SCOVERAGE should allow you to instrument any kind of Scala project. Whether you're using SBT, Maven, or Gradle, it doesn't matter. You can import your sources into SCOVERAGE. There is always a plugin. Or you can make one if you are using something else. So SCOVERAGE produces three kinds of result outputs. The first one is a nice HTML dashboard. You can see what is instrumented or not. You get graphs, and if you go into you get one page per file, and you can see which line has been tested on the file. SCOVERAGE also produces XML outputs. So we kept an old format, which is the Cobertura format. Unfortunately, Cobertura XML are line-based, so we also made a new XML format, which is SCOVERAGE format. In SCOVERAGE XML format, you have information about branch level coverage and statement level coverage as well. The reason why we decided to keep Cobertura is because a lot of tools are using it, and some people really wanted to keep it. So yeah, that leads me to talk about code quality inspection by going through the different plugins. First, you get some tools like Coverage, where you can see your you get some tools like cover rules, where you can see your results in some websites. But the best way to extract those results is to put them into SonarCube. Sonar is a tool that allows you to inspect the quality of your code by giving you statistics and define rules of which parts of your code are actually not well documented, not well commented. So therefore you're able to keep an eye on the quality of your project. Basically, at the moment, the Scala support for SonarCube is not very good. There is a plugin available, but you don't get much rules in it, so it's still a bit difficult to use it with Scala. If you want an example of what you could do with Sonar, if you wanted to instrument your project, is you could define a code rule, like if, for instance, if you have variables instead of vals, it would keep a graph on how much of them you got. Sonar is great in a big team, but it would rather undermine a small team because it's kind of too much information for a small team. So Rado Boronsky decided to develop his own plugin. This plugin allows you to get Sonar SCOVERAGE results into the dashboard. So it comes in as a very nice milestone. You can see the evolution of your statement level coverage and branch level coverage in your dashboard. So this is what it looks like when you've imported SCOVERAGE into the dashboard. You get a percentage of coverage, the lines where it's not tested, and different kind of statistics. Some tools like GitHub's have integrated CI results within their interfaces. At the moment, GitHub works with Travis. So whenever someone does a pull request, if you've implemented Travis, you will get a pass, a waiting, or a fail on the pull request. So that's a small information, but it helps you decide whether it's too early to review it or merge it. You get a link to the build, and you can have a look at what's going wrong or why it passes. If you're using Jenkins, there is a plugin for it, and it will comment on the pull request each time it passes or fails. So this is a possible workflow you could use. Of course, it will depend on the project you're working on, but first you have your build tool, then you instrument your code and check for how much is tested, and then you get in Sonar. Industrialization is one of my favorite aspects of code quality assurance. It also uses your runner, and you can use it to produce documentation, for instance, HTML file, anything you want, really. I guess some of you are familiar with the Play Framework API documentation. This documentation is actually entirely generated by Jenkins CI, and it's pushed automatically to a Git repository. At Misterbell, we generate JSON file. These JSON files are sample results of our API. This way, our front-end developers don't have to run the entire platform in local if they want to start developing. Whenever something changes in our APIs, we trigger a build. It generates JSON results and pushes them to a Git repository. This way, they can work on their JS interfaces without having to get in trouble with all the platform running in local. Deployment industrialization is not really something you want to automate entirely. Some PAS like Heroku are doing it, but it's not really always a good idea, especially on big projects. Of course, you can script most things up in your CI, but these are some tools that can help you make it better. Capistrano is one of the most popular one. It was a Ruby project, but a recipe has been published called Capistrano SBT. So basically, the point of Capistrano is being able to roll back whenever there is a problem. So it helps you doing this fast. And it will also allow you to publish your project and build it on several servers at the same time. The UK newspaper, The Guardian, have released their own tools for it. It's called Magenta and Riffraff. Riffraff is their interfaces for it. You can initiate a deployment and see if and have an history of your previous deployment. And Magenta is their equivalent for Capistrano. The difference with it is that it's entirely coded in Scala. Thank you. I hope this talk has been helpful for you and you enjoyed it. Contribution to SCOVERAGE are always welcome, especially on the SBT plugin. So go ahead and have a look if you're interested. I will add that Misterbell is also recruiting, so if you're interested in joining, you can always check our website. If you have any question, yes?
Here is the question of my friend in Japan. My friend has here said, I want to know about the future of SCCT. Recently, SCOVERAGE, which is a fork of SCCT, seems to be active and to be popular. SCCT is maintained continually. Since coverage is very important, I hope it is maintained continually.
Well, so the question is, are we going to keep working on SCCT, or are we going to keep working on SCCT, or are we just going to keep maintaining SCOVERAGE? Basically, the problem with SCCT is the fact that it's line-based, so it's not really, I mean, it can be useful, but it's not really useful for Scala. We will try to focus on SCOVERAGE, and the idea now is to maximize the compatibility between SCCT and SCOVERAGE. We will try to keep it as easy, it should be as easy as replacing imports and get your coverage done.
Another question. I thought that SCOVERAGE is a fork of SCCT. However, you seem introduce SCOVERAGE explicitly and introduce it. How is the relationship between SCCT and SCOVERAGE.
Well, basically, the two projects are open source and they're like hobby projects on GitHub. Basically, the original creator of SCCT is no longer active and it doesn't publish release anymore. So yeah, we decided to go away from it and create something new. SCCT is a SCOVERAGE is a fork of SCCT, but it has been completely cleaned up. So we've removed a lot of the code that was in there before to make it easier and simple. So yeah, it's not it's based on it, but it's not exactly a fork.
So, are you the contributor of the SCOVERAGE?
I've been helping them with some things, but I didn't participate in the coding of it. So yeah, Samuel did most of the transition, and I recently joined their effort to carry on. I wrote some external plugins, but that's it.
Oh, okay. Thank you very much.
You're welcome.
Can you please explain the workflow of the build pipeline a little more? Where does SCOVERAGE run? Can it run on my CI server and hook into GitHub?
Yes?
I didn't fully understand.
Okay, so you get your CI runner. It executes your SCOVERAGE SBT key or whatever you're using. Then it generates some XML outputs, and these outputs can be used by your Sonar plugin. You see? So the Sonar plugin at the moment is just a jar. You have to install it within your Sonar, and it will look for, you know, in your build, when you build with your runner, there is a small task that will transmit information to your Sonar, and it will look for the XML output and give the information to Sonar. You're welcome. Yes?
What is the overhead of running with this instrumentation? I imagine it slows down the program.
You don't get any overhead. Basically, SCOVERAGE is just, I mean, you use it as a SBT plugin, as a Maven plugin, or whatever. It doesn't change your code. It's only instrumenting it and generating results.
But that takes time, right?
Yes, it does.
So there is an overhead when I run my program with this.
No, because when you run your program, you don't run the test and you don't run the SCOVERAGE.
I'm interested how much longer we might take to test.
That's an interesting question. I don't have the precise answer, but it's not much more longer. It's maybe twice as long. Basically, with AST, it takes a while because it has to create temporary files. The reason for that is it's not like Jacoco, it's not on runtime. Basically, it uses the Scala compiler, and it has to stop between phases. So it generates some files between phases. So since it uses your file system, it will take a bit longer than if you just run the test from scratch. go ahead and then.
Do you know any mutation testing tools in Scala?
I haven't been looking at it. Sorry. Sorry, there was. Yeah, go for it. Yeah. Yeah. Basically, riffraff is not very active. They have open sourced it, but I'm going to try to install it soon. From what I've seen, it's not very difficult, but it's quite a setup. So, sorry? Well, yeah, Magenta is the equivalent to Capistrano. So yeah, it does the put in production thing. Yes.
I was going to add a comment about mutations in Scala. My team uses Scala check extensively. That's something that we've looked at before. It's based off of, I think, Haskell quick check. What was the name? Scala check. Yeah.
Okay. Anyone else have questions? Okay. So sorry for the kind of trouble, but there was a problem with my slides, so I didn't have my notes. I hope you enjoyed it anyway. Thank you.